Number 41 says, according to the U.S. Bureau of the Census, in 1990 there were 22.4 million residents of Hispanic origin living in the United States. By 2000, the number had increased to 35.3 million. And obviously there should be a space right there. Okay, so let's take a look at that. I want to pull out the important information. So 1990 and 22.4 million residents are going to go together. And then we also have some other numbers. So 2000, we see 35.3 million, and those two numbers are going to go together. That first one's going to be my A0 information. So they want me to use this exponential growth model here, in which t is the number of years after 1990 to find the exponential growth function that models the data. So let's think about what our t value would be. How many years went by between 1990 and 2000? Well, I'll just go 2000 minus 1990. And so I know that my t is going to be 10. So next I want to plug in some numbers. So my final amount is 35.3, and that's going to be equal to my start, 22.4, times base e. I don't know what the rate is. They haven't given that to me. So this is sort of like a real-life example. Nobody would tell you what the rate is, but you'd have to use the data from previous years in order to figure that out. And then our t is 10. So we want to solve for the rate. That way we can actually write an exponential model, or actually they just want an equation. So our k is in the exponent, so we need to get it down. We also need to isolate the base first, because right now that 22.4 is multiplying it. So I want to divide by 22.4, and then after that I'm going to take the log of both sides. So simplifying this, I get 35.3 over 22.4. I don't know what that is. I'll put it in the calculator later. That's going to cancel. I get e to the 10k, and then I'm going to take the natural log of both sides. So I get ln of 35.3 divided by 22.4, and that's going to be equal to 10k, so I can bring that down using my properties of exponents and ln of e. We know that ln of e is 1. Those are inverse operations, so they just kind of cancel each other out. And now the only other thing that's happening to the k is it's being multiplied by 10, so I'm going to divide it by 10 to get it alone. So once I put that all in the calculator, I'm going to find k, so I'm going to put that left-hand side in the calculator. 0.0455 if I round to 4 decimal places. So given that I found k, now I can write an exponential expression, or actually an exponential equation. So a is going to stand for the number of residents, and that's going to be equal to our initial amount, 22.4, times base e, and now we have our rate, so 0.0455 times time. Now let's look at that second part of the question. They said, according to the model, by which year will the population reach 60 million? So that's going to be a final amount of population, so we're going to plug 60 in for A equals 22.4. So I'm using that model that we found earlier, base E to the 0.0455 t. And we don't know which year. That's actually what they're asking me. So the first thing I can do is isolate the base. So I'm going to go ahead and divide both sides by 22.4. And then I'm going to simplify that. So I get 60 divided by 22.4 equals base e to the 0.0455t. And now I want to take the natural log of both sides. So I'm going to come over here and rewrite this. I have natural log of 60 over 22.4. And I'm going to use that power rule that says that I can move the exponent down. So I'm going to write that as equals 0.0455t times ln of e, and ln of e, those are inverse operations, so I get 1. And the only thing I have to do to t is to divide it by our rate that we found earlier. And we just plug all of that into the calculator, and I will get our value for time. So that gives me 21.7 years. And since they're asking me which year, not how many years have gone by, I'm going to go ahead and round that to the nearest whole number and think about our starting year, which was 1990. So I need to add 22 to 1990, and that's going to give me 2012 for my year. So that is my final answer.